Hello everyone. Today I will present our topic shortest path. Shortest path problem with Dijkstra. Given a positively weighted graph and a starting node A, Dijkstra determines the shortest path and the distance from the source to all destinations in the graph. The core idea of this Dijkstra algorithm is to continuously eliminate longer paths between the starting node and all possible destinations. To keep track of the process, we need to have two discrete sets of nodes, settlet and unsettlet. Settlet nodes are the ones with a known minimum distance from the source. The unsettled nodes, the gathers nodes that we can reach from the source, but we don't know the minimum distance from the starting node. Before we start exploring all paths in the graph, we first need to initialize all nodes with an infinite distance and the unknown predecessors except the source. As part of the initialization process, we need to assign the value 0 to node A. So each node in the rest of the graph will be distinguished with a predecessor and a distance. Here a list of steps to follow in order to solve the SPP with this Dijkstra. Set distance to start node to 0. Set all other distance to an infinite value. Then we add the start node to the unsettled node set, and while the unsettled nodes set is not empty, we choose an evaluation from the unsettled nodes set. The evaluation node should be the one with the lowest distance from the source. Then we calculate the new distance to direct neighbors by keeping the lowest distance to each evaluation. Then we add neighbors that are not yet settled to unsettled node set. These steps can be aggregated into two stages, installation and evaluation. Then let's see how does that apply to our sample graph. To finish to initialization process, we need to add node A to the unsettled nodes set it to get picked first in the evaluation step. Keep in mind the settled nodes set in still empty. Now that we have our graph initialized, we pick the node with the lowest distance from the unsettled set. Then we evaluate all adjacent nodes that are not in settled nodes. The idea is to add the ages weight to the evaluation node distance, then compare it to the destination's distance. For node B, 0 plus 10 is lower than infinity, so the new distance for node B is 10, and the new precedence is A. The sample applies to C. Node A is then moved from the unsettled nodes set to the settled nodes. Nodes B and C are added to the unsettled nodes because they can be reached but they need to be evaluated. Now we have two nodes in the unsettled set. We choose the one with the lowest distance. Then we reiterate until we settle all nodes in the graph. Here we can see the Java implementation. In this simple implementation, we will represent a graph as a set of nodes. A node can be described with a name, a linked list in the reference to the shortest path distance from the source, and the adjacency list named at adjacency nodes. Here. The adjacency nodes attribute is used to associate immediate neighbors with the edge links. This is a simplified implementation of an adjacency list which is more suitable for the Dijkstra algorithm than the adjacency matrix. As for the shortest path attribute, it is a list of nodes that describes the shortest path calculated from starting node. By default, all the node distance are initialized with integer max value to simulate an infinite distance as described in the installation step. Now let's implement Java this Dijkstra algorithm. That's it. Thank you.